Construct the minimal DFA that accepts strings starting and ending with different symbols given alphabet is equal to a comma b. So each string is of the form AXB BXA, where each string starts with an A and ends with B, and X in the middle can be anything from the alphabet, or it can start with B and end with A, and X in the middle can be anything from the alphabet. The language is a set of all strings where we have AB, BA. These two are the minimal strings, and the rest of the strings are AAB, ABB, BAA, BBA, and so on. Since the language does not have epsilon, the initial state will not be the final state. Let's say Q0 is our initial state. Now consider the minimal string AB and try to construct the skeleton of the DFA on which we will complete the DFA. From Q0, on seeing A, it goes to Q1. On seeing B from Q1, it goes to Q2, which is our final state. So we have accepted this string AB. Now consider BA, which is in our language. On seeing B from Q0, we move to some state. Let's say this is Q3. On seeing A at Q3, we will go to Q4 and accept this string. Now this is the skeleton we have got after parsing the minimal strings. Now check whether each state has transition over all input symbols. Q1 is complete. We can see there is a transition over A and there is a transition over B. At Q1, we have a transition over B. We don't have a transition over A. So how did we reach Q1? We reached Q1 after seeing an A. So what if we see an A at Q1? No matter how many A's I see at Q1, I will be in this state only, waiting for a B to occur so that I can go to Q2 and accept the string. So no matter how many A's I see at Q1, I will be in Q1 only and move to Q2 only when I see a B and accept this string. So Q1 is complete now. Now coming to Q3. How did we reach Q3? By seeing a B. On seeing A from Q3, we can go to Q4 and accept it. What if I see a B at Q3? Similar to the transition at Q1, no matter how many B's I see at Q3, I will be in Q3 itself and wait for an A to occur so that I can go to Q4 and accept the string. So no matter how many B's I see at Q3, I will be in Q3 itself and wait for one A to occur so that if an A occurs, I go to Q4 and accept this string. Now Q3 is also complete because it has transition over A and B. Now coming to Q2, how did we reach Q2? By seeing A followed by any number of A's followed by B. The star here above A means any number of A's, 0 or more number of A's. We reached Q2 by seeing an A and followed by any number of A's followed by B. So what if I see an A here? If I see an A at Q2, we go to Q1 over A because we can see one B and go to the final state and accept that string. Any string in this path, like if it starts with A and on seeing any number of A's, I will be in Q1 only. On seeing B, I go to Q2, and if I see an A, since I need to end the string with B to accept it, I will go to Q1 and wait for a B to occur. I will go to Q1 and wait for a B to occur at Q1 so that I can go to Q2 and accept that string. Now, no matter how many B's I see at Q2, I will be in this state only because the string is starting with A and the string is ending with B. So, this is a valid string in the language. Now coming to Q4. How did we reach Q4? We reached Q4 by seeing one B followed by any number of B's followed by an A, and if we see an A at Q4, we need to accept such string because it is starting with B and ending with A. So we need to accept the string. So I will be in Q4 only on seeing A. What if there is a B at Q4? So on seeing B on Q4, I will go to Q3 and wait at Q3 for an occurrence of A. If there is an A at the end of the string, I go to Q4 and declare the string as accepted. Now this is the minimal DFA for the language accepting strings starting and ending with different symbols.